An example would be a question that says, find the Lewis structure for the compound N2H4. I don't know what that looks like, so let's just go ahead and jump into it. The first thing I do is I take the 4 atoms, and I say which one has the highest bonding preference. Obviously, one of the nitrogens, okay? So what I do is I take my biggest one, or the one with the highest bonding preference, and I put it in the middle, and then I propose a sigma bond framework, okay? Notice that I even put random here, because I'm trying to emphasize that you're not supposed to just know this from the first shot. A lot of students feel confused because they're like, how am I supposed to know this? This is trial and error. So what I did here was I literally just made like the dumbest version that I could. I just put a bunch of atoms around the N. Okay, so I said, okay, one of the H's can go to this N, the other H can go here, the other H can go here, and then one of the N's can go there. Okay, what I'm basically doing is I'm just trying to get the first atom in the middle to fill its octet, and then any other atoms, I'm attaching them somewhere else. So basically, I attached 4 atoms to that N, because that's the most that it can handle. I had 1 hydrogen left over, so then I was like, hey, I'll just put it on that N and see what happens. Okay? So now if I go to my second rule, it says fill in the octets with lone pairs. So that first nitrogen that's in the middle fills its octet. It has 4 bonds. But the nitrogen that I put on the side does not. This one would need 2 lone pairs. So that's what I did in this drawing. I went ahead and added those 2 lone pairs. And now what I did is I go ahead and calculate formal charge. This is the part that's different from Gen Chem. In Gen Chem, usually we wouldn't do this. But in Orgo, I always want you to calculate formal charge. Now that we do that, what we find is that I'm going to have a positive charge on the N, because the N wants to have 5 electrons, but it only has 4. And then I have a negative charge on that N, because that N has 6. Is that cool so far? This is not very good. I can probably do better than this. So what I'm going to do is, if I get to a structure that has lots of charges, or lots of adjacent charges, I have 2 options. Either I can rearrange the sigma bond framework, meaning I can rearrange where these single bonds are. Or I can add pi bonds to remove excess lone pairs. Okay? So in this case, I have 2 different options. I could try to make a double bond, but I would run into a big problem if I made a double bond, right, the way it is drawn right now. The problem is that, let's say that I tried to put a double bond here to get rid of these electrons, then what would happen is that that nitrogen would wind up breaking its octet. This one right here would now have 10 electrons. So there's actually nowhere that I can make a double bond that makes sense. Okay? There's actually nowhere that I can make a double bond that wouldn't violate someone's octet. So that means that I have to change around the sigma bond framework. So what I'm thinking is this. This nitrogen wants more electrons. This nitrogen wants less electrons, and it wants less electrons. The way that I could make that happen possibly is by moving a bond. If I could move one of these H's over here, then what that would do is I would take away 1 lone pair and replace it with a stick. And remember that a stick only counts as 1, whereas a lone pair counts as 2. So let me redraw this looking like this. N, N, H, 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 H. Okay? Now I still have to make sure that everything fulfills its octet. So I'm going to have to add lone pairs. So I'm going to need a lone pair here and a lone pair there. Now I go ahead and I recalculate formal charges and see if this is any better. So the formal charge of this nitrogen would now be 0 because of the fact that it's got 3 bonds and a lone pair, which is the way nitrogen wants to be. And this one is also 0. So that's it. We found a good Lewis structure. Okay? So obviously this one was kind of easy, but I'm just showing you that is the right Lewis structure for this molecule, and we got there through trial and error. We didn't just immediately know what the answer was. All right?